Now we can identify oxidizing agents. An oxidizing agent is something that causes oxidation. It is also something that itself gets reduced. Let's look at a really simple example. Suppose I have this reaction. All right, if I want to figure out what's the oxidizing agent in this reaction, probably you're going to guess that the oxygen is the oxidizing agent, because in fact, that's where the term comes from. Something being oxidized is like something being burned or rusted, and oxygen is an oxidizing agent. It causes things to get burned. All right, if I want to identify the oxidizing agent in any reaction, though, what I'm going to do is assign my oxidation numbers. Assign oxidation numbers. All right, let's do it here. What's the oxidation number on carbon? Well, it's an element, right? And the first rule in assigning oxidation number says assign a 0 to a free element. What about this? It's an element. There's only oxygen in there. So the first rule says assign a 0. What about here? Here we have a covalent compound. It's not an element, so we can't use rule 1. It's not an ionic compound because it's all nonmetal, so we can't use rule 2. I can't just say oxygen has a -2 in here. Rule 3 says all of the oxidation numbers have to add up to the total charge. The total charge here is 0. So, okay, all of the oxidation numbers I assign have to add up to 0. The next rule says, got any fluorines? No, we don't. Go to the next rule. Got any hydrogens? No, we don't. Go to the next rule. Got any oxygens? Yes. The last rule says, if you've gone through the other 5 rules and not been able to assign the oxygen, then assign it now a -2. All right, I've got 2 -2s, and the third rule was saying they all have to add up to 0, because that's what the charge on this is. So if I've got 2 -2s, what does this have to be? It's a +4. Okay, so now we're ready to see what's going on, what the oxidizing agent is. The oxidizing agent is the thing that gets reduced, and it causes the other thing to be oxidized. Well, what's getting oxidized in here? If I look at what happens to the carbon atom, it goes from a 0 oxidation number to a +4, so its oxidation number goes up. So it's getting oxidized. If the oxidation number goes up, it's getting oxidized. What happens to the O2? It goes from 0 to -2, so it gets reduced. Okay, so the thing that gets reduced is the oxidizing agent. We call it the oxidizing agent, again, because it causes the oxidation to occur. It is the thing that causes the carbon to get oxidized. So this is kind of funny terminology. You can also talk about a reducing agent. The reducing agent is the thing that gets oxidized. So one thing is a reducing agent in a redox reaction, and the other thing is the oxidizing agent. The reducing agent is the thing that causes the other reactant to get reduced. The oxygen gets reduced. The carbon is causing that. So you can say that the carbon is the reducing agent. The reducing agent is the thing that gets oxidized. Now let's do, that's kind of confusing to me. Let's do another example. Let's do the example we were talking about before, where we're burning some natural gas. We have CH4 reacting with two O2s to give me, what, CO2 plus two H2Os. That's balanced. You can double check and make sure that I got that right. We want to figure out what's the oxidizing agent here. Well, it's going to be the oxygen again, but let's go through that procedure that we just went through. Step 1, assign all the oxidation numbers. Okay, let's assign oxidation numbers here. This is not a free element, so I can't use rule 1. This is not an ionic compound, so I can't use rule 2. Rule 3 says all of the oxidation numbers have to add up to the total charge. Okay, so all these oxidation numbers have to add up to 0 because that's the total charge. Okay, the next rule says, got any fluorines? Nope. Got any hydrogens? Yes, we do. That rule says if you have hydrogens at that point, assign them a +1. Okay, so I have 4 hydrogens with a +1. What does the carbon have to be by the third rule? If you have 4 +1s, then you have to balance them off with a -4. So what you have here is something that you see a lot in fuel materials. You have reduced carbon here. Okay, it's in a very low oxidation state, you can say. It has a low oxidation number. Okay, let's go ahead and assign the O2. Rule 1 says if you've got a free element, assign a 0. And we do. That's what we have there, so that's easy. How about this one? Well, we just did this. So we did this on the other reaction. The C plus O2 goes to CO2. So I'm going to just do that quick. How about this one? Okay, it's not a free element, so we can't use rule 1. It's not an ionic compound. It's a covalent compound. So I can't use rule 2. Rule 3 says all of the oxidation numbers have to add up to 0. Okay, I'll keep that in mind. Rule 4 says, got any fluorines? No. Rule 5 says, got any hydrogens? Yes. If you've got hydrogens, it says, assign them a +1. So we have 2 +1s, and the whole charge by rule 3 has to add the whole oxidation numbers, the total of all the oxidation numbers, has to add up to 0, the total charge. So if I have 2 +1s, this must be a -2. Now, notice that when I'm doing this for reactions, the number out in front doesn't matter at all. All that matters is the chemical formula that I have here. So don't let that too confuse you. It really doesn't do anything when you're assigning oxidation numbers. All right, now we're ready to see what's getting oxidized and what's getting reduced. If I look at the carbon, there's a huge change in oxidation number for the carbon. It's getting oxidized. Now, if I look at the hydrogens, their oxidation number hasn't changed. It's +1 on both sides, so that's not all that important in the redox process, the electron transfer process. That's telling me that the hydrogen is neither gaining nor losing electrons. But if I look at the oxygen, it starts out as a 0, and it ends up in both places over here as a -2. It's getting reduced. So what's the oxidizing agent? The oxidizing agent is the thing that gets reduced. What's the reducing agent? It is the thing that gets oxidized. So I'm going to want you to be able to pick out the oxidizing agent and the reducing agent in a chemical reaction. You are going to write down the reaction. You are then going to assign oxidation numbers to everything in the reaction. You are going to observe what gets oxidized and what gets reduced. The thing that gets reduced is the oxidizing agent. The thing that gets oxidized is the reducing agent. So you could say O2 is the oxidizing agent. You could say CH4 is the reducing agent. So these are always going to be reactants. So in a multiple choice question, they might say something like, well, it could be CH4, it could be O2, could be CO2, could be H2O as the oxidizing agent. Well, you can immediately discard the products because an oxidizing agent is never a product, it's a reactant. And then you're looking for the reactant that gets reduced. So you'd say O2. And the reducing agent is the reactant that gets oxidized. It's going to be the CH4. Okay? Give it a try yourself in the question underneath.